Hello everyone, this is ML Naruto. Welcome to my channel. Now today I'm going to explain you about HCF and LCM. It's been so long since we meet, and now today the topic is HCF and LCM. So we everybody have already learned these two topics while we were studying in our school. So I won't make things complex, so I'll be explaining in a simplest way. So what is meant by an HCF? So before understanding these two concepts, first of all, we need to know what is mean by a factor and also what is mean by a multiple. So what is a factor? Factor is nothing but if any number that divides the other number exactly, then we say, for example, we have a number that is A and we also have another number that is B. If this A is actually dividing B exactly, then here A is nothing but a factor. Okay. And what is B here? B is nothing but a multiple. So we call B as a multiple of A. Got it? So here A is a factor and B is nothing but the multiple of A. Now, what is mean by this HCF? What is mean by this HCF? HCF is nothing but highest common factor. Highest common factor. In short, we can call it as HCF. So, how to find the HCF now? And I'll explain these. I'll explain this topic with the help of some examples so that you can understand it better. Okay. Now focus here. So how to find the HCF? For example, we are given us a numbers. For example, uh, we want to find the HCF of 2 to the power of 3 into 3 square into maybe 5 into 7 or 4, and also we have 2 to the power of 2, 3 to the power of 5 and 5 square, and also we have 7 cube, and also we have 2 to the power of 3 into 5 to the power of 3 into 7 square. Okay, likewise we are given some kind of numbers along with the powers, so we need to find the HCF. So how to find the HCF here? It's nothing but so out of these three set of numbers, we need to find the common numbers. What are the prime numbers that are actually common? For example, here I'll pick here the least possible power is nothing but the 2 square, right? So here 2 square is the uh, least power that we can at least expect in any of these sets. For example, here just see, here the least item would be 2 to the power of 2, in the sense 2 square, right? So we can at least expect this 2 square in each of the sets. For example, here also in this 2 to the power of 3, we can expect 2 square. In 2 to the power of 3, here also we can expect 2 square. So at least we have 2 square. In the sense, we can write 2 square here, and then what is the next number in the row? That is 3 square, right? So we can at least can we expect uh 3 square in each of the sets? Here we have 3 square. Okay, and here also we can at least have 3 square in this 3 to the power of 5, right? But we don't have any 3 power item in this particular set. Okay, see here we have three kind of sets, right? This is a kind of set, this is a set, this is a set. in this entire set we have 3 square here. So if we can expect at least 3 square in any of these three sets, yes, we can at least expect 3 square in this 3 to the power of 5. But here we don't have any 3 to the power of here we don't have any number that is actually 3, at least with the power 1. Okay, so here we can't even consider this 3. And what is the next number? That is the 5 here. So the least power is nothing but 1, right? So we can at least expect 5 to the power of 1 in every set. So here we have 5. Here also in 5 square we can expect 5 to the power of 1. Here also in 5 to the power of 3 we can at least expect 5 to the power of 1. So I'm taking 5 to the power of 1. Now what is the next number here? That is 7 to the power of 4, right? So what is the least power in each of these sets? 7 square is nothing but this is the least power, right? So we can at least expect 7 square in each of these three sets. So here also we can expect 7 square. Here also we can expect 7 square. In the sense, I'm taking 7 square here. So when you multiply here, 2 2s 4, 5, 7 7s 49. In the sense, 20, 49. In the sense, 980. So 980 would be the HCF for these three set of numbers, right? So this is a way wherein you can easily calculate the HCF. Okay. Okay. So now uh, let's have a look at another example, that is how to find the HCF for these numbers. That is, I have 108 and 288 and 360. These are my numbers, and I need to find the HCF for these three numbers. How to do that? First of all, uh, we need to calculate, or we need to do it separately for each of the numbers. For example, I need to calculate for 108 separately, and I also need to compute it for 288 separately, and then I also need to compute for 360 separately. So how to do that? For example, here we have 108, right? So if we do it, 2 5s, 2 4s, 2 2s, 2 7s, 3 9s, 3 1s, right? So here nothing but 2 square into uh sorry 3 3s here, right? And 3 1s. So two here, 2 square and 3 to the power of 3, 3 cube, right? And when you calculate, uh, when you do the prime factorization for the 288 2, you'll get something like this: 2 to the power of 5 and 3 square. When you also calculate for 360, you will get some 2 to the power of 3 into 5 into 3 square. You'll get like this. So now, how do you calculate the HCF here? So you need to look for the least power. So out of these first set of numbers, what is the least power here? 2 square has the least power. So you can at least expect 2 square in each of the sets, right? So I'm taking 2 square. Here also you have 2 square. Here also you have 2 square. And when you just look at here, what is the least power that you can expect in this particular series here? That is 3 square, right? This is the least power that you can expect. So here you will have 3 square. Here also you have 3 square at least. So I'm taking 3 square. And then what is the other number here? That is 5. Okay, you can't even take this, you can't even consider this 5 number. Why? Because here only in this particular set you have 5, right? But here you don't have, and here also you don't have. So how do we consider that? We should not. So then then what happen is our HCF would be 4 into 9. in the sense 36. So 36 is our HCF. Did you get that? So by doing this prime factorization, you can easily find out the HCF. I'll also explain another way wherein you can easily find out HCF. For example, if we need to calculate HCF for these numbers 513, 1134, 1215. So how to do that? For example, just look for the biggest number, that is 113, oh sorry, 12. 1215 is the biggest number, right? Now you just need to divide it with the smallest number. So or any other number. I mean any other thing. For example, I'm dividing this with 1134 maybe. So what happens here? 1134 now 18 here. So this will be your divisor again. Now you need to divide 1134 with this reminder, that is 81, right? Now if you divide, you'll get this thing like 81, and the remainder would be 324. So what would be the HCF of, so you have only calculated the HCF of 1134 comma 1215. So for these two numbers, the HCF is this thing, that is the quotient here 81. Okay, but we are given three numbers, right? 1134, 1215, 5132. So we need to consider, now we need to calculate the HCF for 513 comma 81. So we need to do that. So how to do that? Just divide 513 with the help of 81. So what do we get? 6, 486 and 27, 81 here. 0. So now what is the HCF here? That is the latest quotient, nothing but sorry, latest reminder, that is 27. This is our HCF. Okay, so finally we can say that HCF for the above three numbers, that is 513, 1134, 1215 is nothing but the 27, right? So this is a way here. And now I'll also explain uh, okay, I'll also explain how to calculate the LCM. For example, we are given 2 square into 3 cube into 5 into 7 square. We also given 2 cube into 3 square into 5 square into 7 to the power of 4. 2 into 3 into 5 cube into 7 into 11. So we are given these numbers and we need to calculate the LCM here. So how to do that? Actually, LCM is nothing but the product of the highest powers, right? So product of the highest powers in the sense, for example, for example, see what are the numbers that we have in each of the sets. Here we have 2, 3, 5, 7. Here also 2, 3, 5, 7. Here also 2, 3, 5, 7, 11. Okay. So now if we calculate the highest powers of each of the numbers, so just tell me what is the highest power for the 2 here. Here 2 square, which is not the highest. 2 cube. So 2 cube is the highest. Here 2. So out of these three sets, I can say that 2 cube is the 2 cube is actually having the highest power. Okay. And now into what is the highest power for this number 3? In the sense 3 cube, 3 square, 3. Out of these three numbers, I can easily say 3 cube is the highest one. And what is the highest power for these three numbers? 5, 5 square, 5 cube. I can easily say 5 cube is the highest number. And what is the highest power for these three numbers? That is 7 square, 7 to the power of 4 into 7. 7 to the power of 4 is the highest number. Okay. And what is the highest number for this 11? Of course, we don't have any 11 here, but we can still consider 11 here. Right. So now the LCM would be the product of these all the numbers, right? You can do the calculation here, you'll get the answer. Okay. So now this is a way, and you can also expect problems uh, like this. What is the LCM for these numbers 72, 108, and 2100? So how to calculate these two? First of all, we need to calculate separately. 72, 108, 2100. So in the earlier thing, we have done prime factorization. So in the same manner, we'll do it now. 2 threes, 6, 1, 2 6 12, 2 18s, 2 9 18, 3 threes, 3 ones. So uh, what is the thing here? So we have 3 twos, right? So 2 cube into 3 square. Okay. Likewise, if you just calculate for 108, it will become 3 cube into 2 square. And if you just calculate for 2100, it will all automatically becomes 2 square into 5 square into 3 into 7, right? And now we need to compute the LCM here. So what is the LCM here? That is the highest power, right? So out of these three numbers, what is the highest power of 2? In the sense 2 cube, right? Why? Because here we having 2 cube, here we have 2 square, here we have 2 square. Out of these three, 2 cube is the highest one. And what is the highest number among these three? Like here we have 3 square, we have 3 cube, here we have 3. So we can consider 3 cube is the highest one. Okay. And now what is the highest number for this 5 square here? We don't have any 5 square number here and here, but still we can consider this 5 square as it is the at least thing that we can consider 5 square. Okay. And what is the maximum power for 7 here? That is 1. Why? Because here also we don't have any 7. Okay. Now if you just calculate all these things, you'll get a value of 37800 is the number here. Okay. So this is a way wherein with the help of prime factorization, you can easily calculate the LCM. Okay. Now I'll also tell you the last way wherein you can calculate LCM easily. Uh, what is the, I want to find out the LCM for 16, 24, 36, and 54. So how to do that? For example, there is a way 16, 24, 36, and 54. Okay. Likewise, you can calculate, you need not to calculate it first separately. Instead, you can calculate it by combining all these things. For example, 2 8s are 16, 2 12s 24, 2 18s, right? And 2 27s. And again, you can choose two fours, 2 6, 2 9s. Here we can with the help of this 2, we can't even divide this 27 perfectly. So we can just um, just just place 27 as it is, and we can consider this time we can consider the number maybe 2, 2 2 is 4, 2 3 is 6, and then it can't be divisible by 2 completely. So we can drop it as it is. We can also drop it as it is, and then now this time you can use 3 here. So with 3 can't divide 2 completely, so I'm dropping as it is. But here 3 ones are 3 and 3 threes are 9 and 3 nines are 27 here, right? And now here we can also use 3 for one more time, dropping, dropping, 3 ones 3, 3 threes 9, right? So now I want to calculate the LCM for these three numbers. So how to do that? You just need to multiply all the numbers, 2 into 2 into 2 into 3 into 3 into 2 into 1 into 1 into 3, right? So if you just multiply all these numbers, so did you get that? How did I write all these things here? 2 into 2 in the sense, see this, 2 2 2 3 3 2 1 1 3. I have just multiplied everything, and now what I have got is some 432. This is the answer. That is the LCM for these four numbers, that is 16, 24, 36, 54. Okay, so that's all for this video. I'll see you again in the next video for some other topic. Good night. Take care. Jai Hind.